Welcome everyone to the Snack and Learn webinar on net zero carbon for master planning. I'll be talking through the methodology and bringing the concept to life with a case study for a project called North Keynsham. And a little bit about myself. I'm Snigdha Jain. I'm an associate director with WSP's Sustainability and Climate Change team. And I've been working in the field of sustainability for the last 14 odd years, advising new developments and existing assets on carbon and sustainability solutions across the UK, Europe, and the Middle East. A little bit of housekeeping. This presentation is going to be about 20 minutes long with time for questions at the end. If you do wish to answer any questions during the course of the presentation, please feel free to pop them in the chat box on the GoToWebinar tab. And the presentation is also available for download in the handouts box should you need it. We'll make a start now. So this is the agenda, which we'll be going through. The first is, I'll be introducing the case study, which, as I said, is North Keynsham. We'll be then talking through the drivers for net zero, defining net zero, delivering it, and finally costing it. Now, the project, first of all. So North Keynsham, it isn't a project that's currently being built or exists. What it was we were appointed to inform net zero carbon for a potential site allocation that was being considered by the West of England. The site itself lies in the West of England, and for those who are familiar with the area, it's on the Bath-Bristol corridor. And it was mixed-use development, residential-led, with employment and social amenities as well. WSP was appointed not only to inform net zero carbon, but also wider transportation strategies and low carbon mobility options for the region. And that subsequently led to follow-on pieces of work, which are to form the evidence base for the next version of the local plan. Now, what does that mean for our international colleagues? In simple terms, it means that we're not just looking at the technological answers, we're also looking at this from a cost, viability, programmatic deliverability perspective, so that it can indeed be stipulated as part of policy. But we need to provide the evidence that to ensure that it is actually deliverable. Talking about the international drivers, starting with those. So we obviously have the Paris Agreement, which is the legally binding international treaty on climate change that was adopted by 196 parties at COP21 in Paris. That treaty aimed to reduce greenhouse gas emissions and limit temperature rise to 2 degrees above pre-industrial levels, and ideally about 1.5 degrees. And that's led to sort of national agreements by various countries to limit their greenhouse gas emissions and aim to achieve carbon neutrality by 2050. That's closely aligned with the Advancing Net Zero campaign, because the building and construction industry is, of course, a dominant part of the carbon emissions that we experience globally. So it's calling on all buildings to be net zero carbon by 2050 and to reduce embodied carbon by 40% by 2030. And we'll explain what embodied carbon is further down in the presentation. At the national level, the UK has had the Climate Change Act for a while, which aimed to achieve carbon neutrality by the year 2050. What's happened most recently is we've had an interim target announced on the 20th April 2021, which is to speed up that process of achieving carbon neutrality. So over the next 15 years and by 2035, we aim to reduce greenhouse gas emissions by 78% or get 3/4 of the way there. And this target is anticipated to become enshrined in law by the end of June 2021. Also, for the first time, the UK's 6th carbon budget will incorporate our share of aviation and shipping, which was not the case in previous budgets, which is obviously quite a major step change and was one of the criticisms levied in the past. At the local level, again, aligning with some of these sort of world leading targets that have been set by the UK at a national level, at the local level, councils also have declared a state of emergency. What that translates into is achieving targets of carbon neutrality by the year 2030 and even earlier in some instances. In the case of our client, in this case, which is Bath and North East Somerset Council, they had also declared an ecological emergency and aimed as a council to double their existing woodland. And that's quite closely aligned with other discussions we've been having at a national level on biodiversity loss and how we stand to lose up to 95% of our biodiversity and species abundance if we carry on as business as usual by the year 2050. And what does that mean, sort of in practical terms? So, if you imagine you saw 20 owls in the year 1970, you'd see just one in the year 2050. Now we get to defining net zero carbon. And the key word here is net. So, what is net zero carbon? It's seeking to achieve a state of equilibrium. So, we are not going to reduce all our emissions down to zero from the get go, but what we are going to do is try and balance them by either sequestering carbon or producing energy through renewable sources, either on site or off site. And this balance calculation, when taken in an annualized way, is called net zero carbon classically. It's just worth remembering that's probably not how energy systems work in a real-time way, but we will address that further down in the presentation. But this is sort of a simplified understanding of net zero carbon. Now, how to scope net zero carbon? Because where do you draw the boundary on what is included and what is excluded? So in a master planning context, typically we take three types of carbon where we are emitting gases, carbon dioxide, for example. Operational carbon is one, which is how we heat, cool, light our buildings. Also, the equipment we use, our laptops, our fridges, our freezers, in our homes, our offices, that's all ways in which we consume electricity and or heat and emit carbon. Construction carbon is the other way, or embodied carbon, as it's sometimes called. That's related to all the materials and the process of building that's involved. So that is how, your brick, your steel, your concrete, right from the time it's mined, transported, gone through various industrial processes to give you your end products or your materials which go as part of the construction process. That is obviously subject to maintenance and replacement, typically at 25 or 30 years. And finally, there are emissions at end of life when we either demolish, deconstruct, reuse, or repurpose some of these assets. Transport carbon, by far the biggest source of transport carbon emissions are the personal vehicles that we use, the private car. We typically, it's petrol or diesel that we're burning, and as part of the combustion process, of course, we are emitting greenhouse gases. On the renewable side, or the positive side, we can obviously generate electricity on site through use of renewable sources such as photovoltaics, which was certainly the case in this context, where we were looking at a combination of both rooftop photovoltaics and ground-mounted photovoltaics to renewably generate the energy that we needed on site. And on the sequestration side, you can, of course, look at both preserving existing woodlands as well as creating new ones to absorb emissions from the atmosphere. And that's the calculations around carbon sequestration. Now diving into a bit more detail into what these different sources are and how do we limit them. So on the operational energy side, these are typically divided into regulated and unregulated loads. Regulated being typically everything that's associated with a building. So that's your heating, cooling, hot water, lighting, fans, pumps. Those are regulated by building regulations in the UK, Europe, and other parts of the world, and are easier to control in some ways and manage and monitor. Then we come to unregulated loads, or user energy, as it's sometimes called, and that's everything to do with your plug-in loads, your appliances, cooking, and so on. And that's a bit harder to manage and control because it is very behavioral dependent. Now, how do we, in a transparent way, understand how far did we get to in our drive towards net zero carbon? So there are organizations like the UK Green Building Council and the Royal Institute of British Architects, which have set climate challenge targets for different years. These are some of them presented on the screen, which limit the amount of energy you can consume on the different years, or set these targets for yourselves. They typically include both building and user energy, worth pointing out, and it's often also sometimes called energy use intensity, or an EUI metric. Now getting to how do we get to these targets? So this is where the scenario modeling that WSP undertook comes into play. So we take a business as usual case and apply different strategies to it until we see how far away we are from various targets. So we are in this context looking at tightening the fabric, which is the the heat losses and gains we have through the fabric. We can control that through the specification process. Then we are looking at whether we are burning gas on site and looking to move to electrification to align with the decarbonization of the electrical grid in the UK, and then using efficient systems such as air source heat pumps in this case to have a lower energy consumption. And then you can look at more advanced standards such as the passive house standard, which is German, to further limit the energy demand you have in the first place through further tightening of the fabric or the building envelope. It's the same set of graphs now presented with photovoltaic panels on the rooftops, and you can see how much easier it is now to achieve those targets we had set. So with a lower level of investment and a lower level of intervention, you can achieve those targets in an easier way. Now we move on to embodied or construction carbon. Now, traditionally, if you look at the pie chart on the top, this was the situation we were in, where most of the emissions from development or a building scale was operational. And the entire focus, perhaps over the last couple of decades and longer, has been on limiting those operational emissions, which we just talked about. However, as we move towards low energy buildings, you can see that the balance has completely shifted, and how construction carbon is suddenly, more than 50% of the pie chart. So the focus definitely over the last few years has been on how do we tackle construction carbon, and when do we spend most of this carbon. It's at practical completion, when of course all the materials are in place, the materials have been carted from the process plants, etc. That's when we've spent most of our embodied carbon emissions. Then at the 25-year lifespan, there's another surge, and that's when you come to the replacement and maintenance cycle. And finally, at end of life, when you either demolish, repurpose, or reuse the asset, essentially. Again, following the similar logic, coming to embodied carbon targets. So this is it's hot off the press documentation that's been released, which is now talking about how to reduce where we are at current building design, which we can see it's at band E, and how we need to shift the peak to a much lower target, which has been set by various organizations, and that's been then further split into a sliding scale of targets, and which have been expressed for different types of assets, which you can see on the left hand side of the screen. again, the same process of how do we achieve these targets. We get back to our scenario modeling exercise. So we start again with business as usual, how things are done in the construction industry today. We then started looking at making swaps of materials. So it could be looking at a higher content of recycled cement and concrete, or recycled steel, and also using less of these materials to begin with through the efficiencies in the design process and all the amazing digital tools we have available to us these days. Then we look at making more fundamental difference to the substructure and superstructure, which is just the structure above and below the ground, and that could be moving to timber construction as an example, which was tested in structure 2. And then once we've exhausted the opportunities there, we then move on to the fabric and fittings and fixtures and so on. So that's when we're looking at, what is the cladding made up of? Do we need to have the ceilings in the first place? We start to get into debates around those ideas. Moving on to transport carbon. Now, transport carbon, as I said, by far, it's the private car is where we are having the big surge in carbon emissions. And you can see, in the UK's GHG by transportation type, the passenger cars are, again, the dominant source of emissions. So when we are designing a master plan development, what do we look at? We look at how the modal split can be shifted. And what does that mean? That means that whether we have all our amenities within, a 10, 15 walking, cycling distance, whether, accessibility has been provided to us and convenience is there so that we can walk and cycle everywhere. And then we have good links to public transportation, or the residents of the development have good links to public transportation. And finally, they are reliant on, for a small percentage of their trips, they are reliant, the users are reliant on either car sharing, or use of individual cars. And how do we solve that sort of last piece of the puzzle, which is the use of the private car, where we are reliant on a percentage of transportation trips by private cars? We can look to the move towards electric vehicles, which is what we've been doing at WSP in this case. It's both, you can see on the left hand side how electric cars afford more efficiency compared to, say, petrol or diesel cars, but also how they have much lower emissions because they take advantage of the decarbonization of the electrical grid. So in the years 2040, 2050, when the carbon emissions from the UK national grid are very low, then we are talking almost a negligible proportion of emissions as a result of the electric car. Moving on to the sequestration side. So at WSP, me and my team, we used a tool called Woodland Carbon Code, and that uses a range of factors that you can see: yield, class, management, species scenarios, and so on, to say how much carbon can we sequester per tree hectare. So you can see over a period of 100 years, it's about 600 and above. And at the halfway point, it's about 400, 450 tons of carbon per hectare, which may sound like a big number, but you have to look at it in the overall picture. So that's when we pull together how much we are emitting and how much we are generating through renewables, or sinking through the creation of woodlands, for instance. So on the top of the dotted dash black line, you can see the emissions from operation presented in a cumulative way. And the reason it's in the form of a curve is because the impact is reducing over time because the grid is decarbonizing. And we start with a significant number on construction carbon. That's because we've spent the majority of our carbon when the buildings are constructed. And then we have that kink at the 25-30 year lifespan when replacements happen. And on the bottom, you can see, this tiny percentage that is being sequestered by the woodlands we had on site, and that's just gives you, an idea of scale, essentially. However, we always say, carbon is one of many things, and often these strategies do need to be looked at holistically in terms of, what woodlands afford in terms of amenity, well-being, climate resilience, air quality, and water quality. And the graph at the bottom is the amount we were earmarking in terms of spatial allocation for the solar farm to generate electricity to meet our needs on site. As I said, we did look at each of these strategies and weighed pros and cons against different frameworks. There are, frameworks like the six capitals method, where you can weigh strategies of pros and cons into how they perform against the different capitals. We looked at one of many things we looked at was the UN development goals, and aligned ourselves with some of the key targets of good health and well-being, sustainable cities, and responsible consumption and production. Finally, and quite importantly, on costings, as I said at the beginning, what we needed to really know was what gives us the best bang for our buck, essentially. So we are always looking at the cost implications at the same time and the carbon reductions we are getting for the different strategies. So an exercise was undertaken to estimate where do we get those biggest benefits from a costing perspective. And this was, again, to inform the evidence base so we could actually put that into policy further down the line. And finally, last slide, conclusions and key takeaways when we are looking at net zero carbon in a master planning context. You have to start with being clear on the definition and the scope. What is net zero carbon and what's included and excluded. When always keep an eye on the removal side. So if you are relying on renewable energy on site, for instance, as your primary mitigation, you have to understand how much space you need almost from the get-go. So for our solar farm, we needed up to 20%, 10 to 20% of the site area in some instances. So that was, quite a crucial calculation for us to understand how much space we had to earmark from the get-go. Be mindful of wider unintended consequences. Carbon is one of many things that makes a place amazing, and carbon can sometimes compete with other considerations such as air quality, such as daylight. You can have very low carbon by having a very small window in a very dark apartment, but that is not necessarily the right thing to do. So carbon always has to be balanced with other considerations. Some key future trends to keep an eye on. Nothing will change the fact that a behavioral shift is needed, both in the way we design developments and the way we use our developments. Ultimately, it all comes down to how much can we reduce that original demand to begin with, because once we've created that demand, we're always trying to develop solutions to tackle it. So the key is always there, how we can have the behavioral shift. Keep an eye on technological innovation. There are other technologies being explored and innovations happening, for example, in the space of hydrogen. That's, definitely one to keep an eye out in the future for, as well as existing technologies are, PVs and EVs are becoming cheaper and more affordable. Almost, there's been a rapid technological innovation in that space. And something I touched upon in the beginning, we have to understand that the energy system is not static, whilst net zero carbon is a static construct. In reality, the grid carbon intensity changes hourly, half hourly, and the demand of our energy, when we need to consume energy also changes, in a half hourly fashion. So we do need to start moving towards management of this energy system and to align ourselves with what's happening and not just look at a static construct, because that is not necessarily aligned with best decisions in a dynamic system. And ultimately, never to forget, we are always creating places for people, and we have to bear in mind, the idea of species abundance and the well-being of the users of these spaces, and how carbon is not taking away from quality of life in any way. Thank you for your time, and we'll take any questions now.
Thank you, Snigdha, for your presentation. Before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download a PDF version of the presentation from the handout box. I will start with the first question. Is there a drawback in the concept of net zero?
Yeah, I think I touched upon it in my last in my last takeaway. It is potentially the fact that net zero is a static annualized construct. That's what it is. We have oversimplified to some extent the whole approach to net zero, where we take a single factor over the course of the whole year and multiply our consumption by that. But that is definitely not what happens in a real way. Certainly like I mentioned, the electrical grid is rapidly decarbonizing and changes over season, changes on a daily basis. So we have to align ourselves with what's happening in a dynamic way.
Thank you. We have here two questions. I will read them both. Do you see the conversation developing around making improvements to the energy efficiency of listed buildings? And also, can you keep the historical importance of buildings but make them future ready?
Yeah, so it's a very good question. So it is, of course, the moment you move to existing assets, it is more challenging. And when you move to listed buildings, the level of difficulty does keep increasing. One thing I would say there is, always look for the easy wins. The fact is that this presentation and a lot of the scenario modeling has been theoretical, and it has been proven that we are looking at a big performance gap between what is happening in reality and what is happening, using theoretical frameworks. So it is crucial to use some of those, making sure we are monitoring the energy we use, making sure we are managing that energy, we are not being wasteful in any way. And most of the audits that WSP undertakes, on a range of existing assets, that's one thing we've always found, that energy management is kind of like top of the agenda, and you can just save a phenomenal amount of energy, not by necessarily doing the upgrade straight away, but by monitoring, sub-metering, and managing the energy that's being wasted.
Thank you. How much does concrete add to the embodied carbon?
It really depends on how much concrete you're using in the first place. But yeah, steel and concrete are often some of the biggest hotspots in an embodied carbon calculation. That they can be up to like 30% of the, or more even, of the overall picture, essentially. So yeah, it can be sort of one of the most significant hotspot in a whole life carbon calculation.
Thank you. There's a question here about slide 21, bank for your buck assessment, sorry. Are these a separate return on investment calculation or business case that can be shared with clients?
Yes, so one of this is this is a snapshot from an evidence base we are creating for Bath and North East Somerset Council, and with the council's permission over the next coming months and when the study is finalized, and that certainly should be made publicly available for use across the industry.
Fantastic, thank you. We will take the last question. There are additional more. Apologies, we don't have time today. The next one is, are there any potential unintended consequences in having this singular focus on net zero?
Yeah, I think there's two certainly aspects that come to mind straight away. I think one is around the health and well-being of the residents, making sure that that is not compromised in any way, and balancing that with energy reductions in energy that we have to make. As well as social value is the other thing that comes to mind, that we have to make sure that the whole low carbon agenda does tie in with what what the supply chains are doing. Are we able to use local suppliers? Are we able to upskill the local, and make improvements to local employment, jobs, apprentices? How can we tie this in with what's happening, in the wider community?
Thank you. We are at the end of our webinar session, so please feel free to follow up directly with Snigdha via the contact details shown on the screen. Thank you very much for presenting today, and thank you everyone for joining. It was a pleasure and a very interesting presentation. Thank you very much, everyone.
Thank you for your time, everyone.
Thank you.